Nat 405 Physics, Newton's first law. The key areas we will cover today are how forces are detected, friction, balanced and unbalanced forces, and the definition of Newton's first law. Forces. Forces can be detected when they change the shape of an object. Forces can also be detected when they change the speed of an object. Finally, forces can be detected when they change the direction of an object. In summary, forces can be detected when they change the shape, speed, or direction of an object. We can demonstrate this using some plasticine or Play-Doh. Imagine you are holding some Play-Doh in your hand. You can squash this Play-Doh. This is you changing the shape of it. If you want to change the speed or direction of the Play-Doh, you could throw it. The magnitude or size of a force can be measured using a Newton balance. And the unit to measure force is the Newton, named after Sir Isaac Newton. Friction. Friction causes a force that opposes the motion of an object. Friction is caused by the contact between two surfaces. We have two examples just here showing high friction and low friction. If we slide rough surfaces together, like sliding the bristles of two brushes together, it's difficult. This is because there is high friction. Looking at low friction, if we slide smooth surfaces together, like sliding the backs of two brushes, this is easy. So high friction, it makes it more difficult to slide rough surfaces together, and low friction makes it easy to slide smooth surfaces against each other. High friction. The force of friction can be increased by making the surfaces rougher. Our picture here shows a road. It's been resurfaced to make it rougher. This could be because there were often car crashes beforehand. By making the road surface rougher, we increase the friction between the tyres and the road surface, meaning the cars can grip more on the road and so there'll be less crashes. Low friction. The force of friction can be reduced by making surfaces or shapes smoother or more streamlined. What we have just here is a picture of two professional cyclists. You can see the shape of their helmets just here is very smoothed, and the wheels are different from normal bike wheels. This is reducing the force of friction and making it more streamlined so they can go faster. Balanced forces can happen when two forces that are the same size as each other act on the same object but in opposite directions. We have an object in the middle just here, and there is a force being applied to the left of the object, 20 newtons, and a force being applied to the right of the object, again 20 newtons. These forces are in opposite directions, and they are the same size, therefore these are balanced forces. Our second diagram shows a box again. This time there is a force acting upwards, which is 15 newtons, we can see that just here. And there is a force pulling downwards, again 15 newtons. Because these forces are acting in opposite directions and they are the same size, again, these are balanced forces. This is the same with our third diagram as well. We have a box, we have forces acting in opposite directions on the box and they are the same size, both 30 newtons, therefore the forces are balanced. From practical work or research, find out what happens to an object when the forces acting on an object are balanced. Pause now to give yourself time to do some research. What you would find out from this research is that when objects are at rest, or if they travel with a constant speed, the forces applied to the object are said to be balanced. For example, we have a car just here. This car could be going at 30 miles an hour, for example, and if it was going at a constant speed, the forces applied to it would be balanced. We have two forces just here, the frictional force and the engine force on the car. We can see that the frictional force is 2000 newtons and the engine force is 2000 newtons. Therefore, the forces are balanced and so the car will carry on going at the same speed. If we increase one of these forces, the car will either accelerate or decelerate. Newton worked this relationship out and called it his first law of motion. We can state Newton's first law of motion as a stationary object will remain at rest, or a moving object will remain with a constant speed when balanced forces act on the object.